Okay, I've tried to make this video 4 times. This is my 5th attempt, and it has to go right this time or else there's going to be problems. Alright, the learning objective for this video is to be able to factor higher order polynomials. Higher order means polynomials of degree larger than 2. So these would be cubics, quartics, and quintics, and 6th degree, 7th degree, as high as you want. First, let's do some stuff that we already know how to do. So as a warm-up, factor these 3 polynomials. Pause the video, and we'll talk about it afterwards. Okay, so as we look at this first one, the first one has a greatest common factor between all of them. The second one is a quadratic trinomial, and the third one is a difference of squares. And these are the 3 types of factorings that we already know how to do. We've covered it on the last few videos and done it in class. And if you correctly factor them, they will turn into this. The first one has a greatest common factor of 5g squared, leaving you with g to the third plus 2g minus 6. The second is a quadratic trinomial, which factors into the product of 2 binomials, h plus 7 and h minus 4. The third is a difference of squares that factors into the product of 2 binomials, j plus 8 times j minus 8. So this is what we already know how to do. What we're going to do today is we're going to take these and do them in combination. So let's try one out. Factor this completely. So that's a new word for you, factor completely. Pause the video and give it a shot. Alright, this is not a quadratic trinomial, it's not a difference of squares, but it does have a GCF. The GCF here is 3p to the third, which leaves me with p squared minus 9. A student just handed me a cupcake. That doesn't matter. Okay, so we factored it. Great. But the question is, have we factored it completely? Completely means factor it to the point where there's no factorings left to be done. And if you look at this expression, this binomial right here is a difference of squares. That's a square, or supposed to be. So we can actually go further on this one, and that's what's new here. We're doing greatest common factoring, we're doing difference of squares, we're doing quadratic trinomials, but it's going to be in combination. There's still a 3p to the third, and then p squared minus 9 factors into p plus 3 and p minus 3. And now we check to see if we can factor anything further. Monomials can't be factored any further. This binomial can't be factored any further, and this binomial can't be factored any further. So this is factored completely. Now there's something really important to note about this. Always factor the GCF first. There are some situations in mathematics where it's not a good idea to factor the GCF, but in Algebra 1 and most of your high school math classes, you won't run into this problem. So whenever you see these, always take the GCF first, right away. Let's try that out with another example. Factor this completely. Pause the video and give it a shot. Okay, so as we look at this, always look for a GCF first. There is a GCF here, so it's going to be 5y squared comes out, leaving you with y squared minus 8y plus 12. So we factored it. Is it completely? No, because this is a quadratic trinomial, which means we can factor it into the product of 2 binomials most of the time. The 5y squared is still going to be in front, and then this is going to factor into y minus 6 times y minus 2. None of those can be factored any further, so we're finished. Factored completely. Let's try another one. Give this a shot. Looks a little strange, but it's actually surprisingly simple. Give it a go, and we'll talk about it in a second. Okay, so if you look at this, this is a perfect square, and this is a perfect square. This is a difference of squares, and it factors into w to the 12th minus 16. 256 is 16 squared, times w to the 12th plus 16. Can we go further? Yes, because this is another difference of squares right here. This becomes w to the 6th minus 4 times w to the 6th plus 4. And we still have w to the 12th plus 16. Are we done? No, because this is a difference of squares, and we're left with w to the 3rd minus 2 times w to the 3rd plus 2. There's still a w to the 6th plus 4, and there's still a w to the 12th plus 16. Can anything else be factored? No, none of these are difference of squares, so we're done. This is our factoring. That was kind of fun. Okay, let's try another one. This one's going to look a little different. See if you can figure this out. Pause the video and try to work this one out. I'll give you a hint. It's a trinomial. Not a quadratic trinomial, but a trinomial. Okay, so there's no GCF, right? We always look for a GCF first. There's no GCF. And you probably haven't seen this yet, but when you have a pattern of to the 4th squared and then a number, to the 4th squared and then a number, you can actually factor it into two binomials. Do you know what's going to give me w to the 4th? It's going to be w squared and w squared. So if we multiply w squared times w squared, it'll give us w to the 4th. Then, to get a minus 18 and a negative 7, I'm going to do minus 9 plus 2. And we can check to see if we're right. By multiplying it out, there's w to the 4th plus 2w squared minus 9w squared minus 18, which gives us w to the 4th minus 7w squared minus 18. So it checks out. So when you see this pattern to the 4th squared and then just a number, you can actually factor that into the product of two binomials. You'll just have quadratic binomials instead of linear binomials. Okay, so that checks out. So now we have to see, did we factor it completely? Can either of these be factored further? Yes, this is a difference of squares. So this factors into w plus 3 times w minus 3, and we still have a w squared plus 2. Can any of those be factored further? No, so we're done. That was kind of cool, huh? W to the 4th, w squared. Huh? See if you can do this one. Pause the video and give this a shot. Okay, so we're always going to look for a GCF first, and there is a GCF. So we're going to pull that out. That's 2a, which leaves me with a to the 4th minus 9a squared, right? Yep, plus 20. And now we have that same situation where it's to the 4th squared and then a number. A to the 4th, a squared, and a number. The 2a is still in front. And then this factors into a squared minus 5 times a squared minus 4. That was pretty cool. Are we done? No, because this is a difference of squares. So we got to do one more step, and we're left with 2a in front. A squared minus 5 is still there. And then a squared minus 4 becomes a minus 2 times a plus 2. Are we done? Yes, none of these can be factored any further, so we factored it completely. Let's try it one more time. Factor this, pause the video, and make it happen. Okay. Always look for the GCF first. GCF first, GCF first. Oh, this one's broken. Sorry, I screwed this one up. Let's try that again. Okay, sorry about that. I think it works now. I hope it works now. Okay, so we take a look at this, try to factor this, and pause the video, and we'll talk about it in a second. Okay, so this one's similar to the ones we saw before. There's a GCF. Always take the GCF out first. We're going to pull a 3d squared out, which will leave me with d to the 4th minus d squared minus 12. And now we have that same pattern to the 4th squared and 12. So we're going to factor this down into 3d squared times d squared minus 4 and d squared plus 3. Good? Are we done? No, because there's a difference of squares right here. This will leave us with 3d squared times d plus 2 times d minus 2 times d squared plus 3. Is it factored completely? If you take a look at these, none of those can be factored any further, so we're done. Factored completely. All right, so moral of the story is we're doing the same things we did before, GCF, quadratic trinomials, and difference of squares, but now they're in combination. Always look for the GCF first. Always look for the GCF first. Watch out for these types, whether it's to the fourth, squared, and then a number, and make sure that you go all the way to where none of them are can be factored any further. This was a really hard video to make, and I'm glad I am done with it. You might be too. Bye.